Welcome to Miss Casus's magical world of math. Ooh. Ooh. Beautiful math. Origami. Let's get serious. This year, you're going to be learning how to think like a mathematician. You're going to be problem solving. Writing functions. Making connections. Learning about finances and business and planning for your financial future. Building numeracy so that you understand all those statistics going on Facebook and everything happening on the news.
Harmless, either. An analysis of Nielsen data from the Knight Foundation shows a widening gap between liberals who say they trust the media and conservatives who say they don't. The Pew Research Center finds that the most...
And practice, practice, practice. We always have to practice so we get better and better. Making meaning of situations and problems is the first step to solving them. And that's what this year is about, and that's what this first assignment is about. We want to make sure that we're reviewing all of those important numeracy skills that you've been learning your whole life. And we want to build on them so that you guys are super strong and understand everything that comes your way. Couple things that you're going to need to remember for this first Delta Math. The first is that whenever you have an expression, no equal sign, and you know what a variable is equal to, you're going to plug it in everywhere you see the variable. So this is an x, and here are the x's. And you're going to put parentheses around them. So parentheses where the x goes, everything else stays the same, and then you're just going to plug in that number where the parentheses are. Okay? And then just work that out. The next thing to remember, 5 plus x. Well, how many x's do I have here? I only got one. That means if there's no number in front of the x, there's an invisible 1, and you need to write that in. So whenever you see an x or a y or any letter without a number in front of it, write in that 1. Last thing, if there's a plus or minus in front of parentheses, for example, 4 minus parenthesis 3x plus 8. You have to remember that the same thing where we put a 1 in here, we put a 1 in here. So anytime there's no number in front and there's a plus or minus in front, like that. No number, plus or minus, no number, plus or minus, we put a 1 in. That way we know to distribute the -1 to everything inside. Okay, we're going to practice all of this stuff. If you're doing a Delta Math and you don't know how to do it, click Show Example on the top and look at the example, or click Watch Video and watch the video. Good luck. If you have questions on the Delta Math, email me and I can do a one-on-one tutoring session with you. But why do we need to know all of this anyway? And where does it all come from? Let's find out how math is used in the real world. We call that applied mathematics. Let's take a look.
The mathematics we learn in school doesn't quite do the field of mathematics justice. We only get a glimpse at one corner of it, but mathematics as a whole is a huge and wonderfully diverse subject. My aim with this video is to show you all of that amazing stuff. We'll start back at the very beginning. The origin of mathematics lies in counting. In fact, counting is not just a human trait. Other animals are able to count as well. And evidence for human counting goes back to prehistoric times, with check marks made in bones. There were several innovations over the years, with the Egyptians having the first equation, the ancient Greeks making strides in many areas like geometry and numerology, and negative numbers were invented in China. And 0 as a number was first used in India. Then, in the golden age of Islam, Persian mathematicians made further strides and the first book on algebra was written. Then mathematics boomed in the Renaissance along with the sciences. Now there's a lot more to the history of mathematics than what I've just said, but I'm going to jump to the modern age and mathematics as we know it now. Modern mathematics can broadly be broken down into two areas. Pure maths, the study of mathematics for its own sake, and applied maths, when you develop mathematics to help solve some real-world problem. But there's a lot of crossover. In fact, many times in history, someone's gone off into the mathematical wilderness, motivated purely by curiosity and kind of guided by a sense of aesthetics. And then they've created a whole bunch of new mathematics, which is nice and interesting, but it doesn't really do anything useful. But then, say, 100 years later, someone will be working on some problem at the cutting edge of physics or computer science, and they'll discover that this old theory in pure math is exactly what they need to solve their real-world problems, which is amazing, I think. And this kind of thing has happened so many times over the last few centuries. It's interesting how often something so abstract ends up being really useful. But I should also mention that pure mathematics on its own is still a very valuable thing to do, because it can be fascinating and on its own can have a real beauty and elegance that almost becomes like art.
This is going to be an amazing year. I can't wait to learn math with you guys. Let's get started.